In this video, I'm going to show you how to compute the hash tables and deal with collisions via separate chaining, linear probing, quadratic probing, and double hashing. Okay, so if there's no collision, okay, the hash that we use is going to be the same as the hash we use for separate chaining. Okay, it's just the regular hash. It's x mod 7. It's a modular hash. So all we have to do, okay, is first thing you want to do is figure out how you compute the modulus operation on your calculator. Typically it's a shift. Okay, you're going to push shift and then you're going to push the number, shift, push mod, and then the other number. In Excel, the way we compute the mod is using this this function, the mod function. So mod numerator and then denominator. Okay, so all of these, right, when we compute the hash is going to be the same unless there's a collision. If there's a collision, then we're going to use these other techniques for computing the next index. Okay, so this is our main one right here, and then we're going to check to see if we have any collisions. I'm just going to put a little highlight here. Okay, maybe use a different color. Let's go with, I don't know, that. Okay, and then if we have a collision, we're going to identify it. Okay, so we're going to say equals mod. All right, and then we're going to say this is the numerator, the key, and then the denominator is going to be the m. M is 7 in this case. Okay, so here we are. We're going to do that for all of them. And look, 3 is taken, 6 is taken, 4. Now we have a collision here. This guy has a collision. Maybe I should let's just use a different color here. Okay. 1 hasn't been taken, 5, and 0. Okay, so the only one that has a problem is this guy. In separate chaining, though, we're not going to have any issue with having these guys at the same index because we're making linked lists. So there's no issue here for separate chaining, and I'll actually draw everything out here in a second. Okay, actually we can do that right now. So at index 0 we have 39, 20. Okay, at index 1 we have 22. Right? At index 2 we have nothing. At index 3 we first have 23, 41, and because we're making linked lists here, right? And then after that we have 430. Okay. At index 4 we have 28. What is it? Where is it? Index 4, 28, 39. At 5 we have 397, and at 6 we have 42, 34. All right. Okay. Now you can take a look at these. That's basically how our hash table would look for if we use separate chaining. Okay, so we basically make the hash table, the heads. We put the heads of linked lists at every index in the hash table. Okay, let's move on to linear probing. Okay, so here again we're going to use our regular algorithm. Okay, the x mod 7 until there's a collision. Okay, so let's go in here and say equals mod, and then it's this number, and then we have 7. Okay, we got to do this one at a time. So 3 is good. Nothing has been taken. 3 has not been taken yet. And then we're going to go to 6. That's good too. Then we go to 4. That's good too. And then we hit 3 again. Okay, just like we said over here. Now, what do we do here? Well, this is going to be different, right? This one is going to be what we need to do is we need to take whatever h of x is. So let me go like this, equals, and then I'm going to go like this. This is h of x, okay, plus, right? And now I is going to be 1 because we're going to increment I. It was 0. If we started with 0, it's going to be the same thing as our regular x mod 7. So let me add 1. Okay, and now we're going to, this guy is going to be the numerator. And we're going to see if there's a collision. So it's equals to mod, like this, and then 7. Okay, and if there is still a collision, then we have to increment I by 1. So here, look, there's a collision. We're at 4, right? So because we already have 4 filled and we're using linear probing, not chaining, so now what we need to do is we got to go into our equation here and make this a 2 and see if it's been taken. 5 has not been taken, so we're good. Okay, let's go back to our original equation. Is mod of 22 and 7 and see if there's a collision. Is 1, no collision, same as here, we're good. Let's do the next one. Let's just pull this same formula down. We shouldn't have any other collisions. Well, let's see. 5 is, oh, okay, here we are. 5 is taken, right? So now what we need to do is we got to take this formula, right? And try again with actually this formula right here. We can use this one. So this equals, right? Okay, let me put in the mod. All right. So now it's basically h of x plus, now I'm going to put 1, right? And then 7. All right, so we're going to go one more down and see. Is 6 taken? Yes, it is. So we can't go there yet. We have to increment. Let's go back to the formula. Make this a 2. Is 0 taken? No. We're okay. All right, let's go back here. This equals mod, and then it's this guy, and 7, and see if we have a collision. 0 is taken, so what we need to do is we need to go back to this formula here. Let's go up here. I'm going to pull it down, but I'm going to start at, I got to rewrite the formula because it started at 2. I'm going to try 1 first. Is 1 taken? Yes, it is, so we can't use it, so we got to go back and change it back. Try 2. Is 2 taken? No, it is not. Okay, so no further collisions, and that's our table. Let's take a look at what this looks like. So at 0, we have 397. Okay, at 1, right, we have 22. At 2, right, we have 3920. Okay, at 3, we have 2341. Okay, at 4, what's at 4? We have at 4 we have 2839. At 5, we have 430. And at 6, we have 4234. Okay. Okay, let's take a look at the next one. We're going to use quadratic probing this time. Okay, so again, we're only going to apply this formula when we encounter a collision. Okay, so we're going to use our regular hash. So let's go here, say equals, and I could say mod this guy and 7 until we encounter a collision. Right, so let's go here. So 3, 6, no collision. 4, no collision. Okay, collision. Okay, so we're here. Let's go in, and we need to use this new formula. Okay, so let me go like this. I'm going to take, it is a mod, but instead of A7, what I'm going to do is, here's my, my formula is going to go in here. It's going to be h of x, okay, that's our h of x, plus, now, I'm going to go with, I'm going to start with 1, and then squared. Okay, because c is 1, so I'm going to try 1 squared. Then I'm going to try 2 squared, then I'm going to try, okay, so let's see if it's taken. 4 has been taken, so I need to go in, and I got to increment I. So this was 1, I got to increment it to 2, and see if it's taken. Is 0 taken? No, so it's good. Okay, so let's go, let's continue on. I have to say equals, use our standard formula, mod of the key, and 7. Is 1 taken? No. Okay, so we're good. Is 5 taken? Nope. 0 is taken, so we got to go back in and take our formula. So where do we have a collision? We had it over here. I'm just going to copy this formula over, copy, and down here, paste. So this is the collision formula. I have to start at 1. Okay, so let's start there and see, is 4 taken? Yes, so I have to try changing it to I to 2. Is 0 taken? Yes, it is. So I need to go take I and make it 3. Is 5 taken? Yes, it is. Let's make this 4. 5 is taken. Let's make this 6. Oh, sorry, 5. Is 0 taken? It is. So we got to make this, try 6. Is 4 taken? I must have made a mistake. Probably I made a mistake somewhere. Let me see. I tried 1, right? I tried 2. Well, let's just try again. I might have made a mistake here. So 3. Oh, okay. 3 is still taken. What am I looking for? I'm looking for 2. I got to get index 2 somehow. Let's go with 8. 4 is taken. Let's try 9. 0 is taken. Let's try 10. 5 is taken. Try 11. 5 is taken. This one's giving us some issues. Let's see. Let's try 12. 0 is taken. Let's go to 13. 4. Let's try 14. 3 is taken. What am I looking for? Did I miss something somewhere? I may have. Here's 4. Let's try again. 0. We're looking for 2, right? We're looking for... Did I make a mistake somewhere? Okay, let's try it again. So it's 0, right? So if I just go... I'm never going to hit 2 because... Well, if I mod 7, it might at some point. Right? Because I've taken everything. 1, 3, 4, 5, 6, and... Okay, 0. So really, I gotta keep going until I hit... Until I hit 2. There's nothing I can do, right? 18... 19... 20, there's a collision. 21 squared, I hit 3. 2 squared, I hit 4. 0. 5. Basically, I got to keep going until I hit 2. Am I ever going to hit 2? Unless I missed a number somewhere. Keep going. 4. At some point, I'm going to hit 2. Let's try 29 squared. 30. 31. At some point, wonder, okay, so what we're going to do actually, let's just go to the side here. And what I'm going to do is I'm going to put the numbers from, so this is going to be I. And put the numbers, this equals whatever came above, plus 1, plus 1, right? Okay, and this one is going to be, so it's going to be basically 3, right? Plus this guy squared. So it's going to be equal 3 plus this squared. Okay. So I'm going to continue this one. We're just going to go search through. I'm going to do this. Let's try that. We tried them, but we basically need to hit here. It needs to be hitting 2. See, 0 was taken. Actually, yeah, we got to hit 2 somehow over here. That's the only way that we can not have a collision. So if I go here, and keep going. See if I reach 2 at any. Oh, I forgot one point. Take the modulus, right? We have to go mod 7. So we have to say it equals to mod this squared and 7. And now we can take this. So we need to have 2, and that's the only way that there's going to be no collision. Do we have anywhere where we reach 2? Okay, we're going to have to keep going. At some point, we're going to have to reach 2 at some point. Wow, it's really... It's 5, 4, and 3. Huh, interesting. Okay, so we're going to have to take a look and see. Okay, so I've tried thousands of options here. So for this algorithm, actually, you're never going to hit, right here, you're never going to hit a 1 or a 2 if you use this quadratic probing with C as 1. Okay, so at the end of the day, right here, after you might have to put into your algorithm that if you've tried many times, basically look for anywhere in your hash table that's empty and place it there. So really what we have to do is we have to place this at 2, because it's the only place that we can actually put it. Okay, so because our table has 7 items and we only have 7 keys, we have to place them there. So at the end of the day, quadratic probing, this is going to be a problem because you're never going to hit 2. Okay, you're never going to get 2. And you only have 1 spot left, so that's the only place it can go. Okay, so for quadratic probing, let's put it in. So at 0, we're going to have 430. Okay, 1. All right, 0 is 430. 1, it's 22. Okay, 2, we're going to have 39, 20. That's the only place we can put it. 3, we're going to have 23, 41. 4, let's see, 4 is at 2839. 5 is 397 is at 5. And at 6 we have 4234. Okay. Okay, let's do the last one, double hashing. Okay, so here if we have a collision, we're going to implement this algorithm. Okay, so let's just run the same algorithm. So we're going to take the mod of this guy and 7. Okay, so first we have 3, that's fine. I mean, really, we're going to collide at 3, right? We're going to collide right over here. Okay, so now we have to implement our algorithm. So at 3, we're going to do what? We're going to implement this algorithm. So what we get is we get okay, mod, and it's going to be h of x, so that is that guy, right? Plus, okay, let me go, plus, now we're going to say 2 times, what's x? X is 430, minus 1, okay, so now we close that, and then 7, and then close that off. And so we should be at 1. So there's no collision there. Let's go back to our original algorithm for hashing this guy and 7. See if we have any collisions. So we collide with 1. So now we got to run our double hash algorithm here. Let's see what happens here. Let's bring this guy down. And that brings us to 2. So we have no issue there. Okay, let's go back to our original algorithm. This guy at 7. We have 5, there's no collision there, and then this one will bring us to 0, no collision there. Okay, so let's input where everything is. So we have 39, 20 is at 0. Okay, 1 we have 430. 2 we have 22. 3 we have 2341. At 4 we have 2839. At 5, let's go here, 5 we have 397, and at 6 we have 4234. Okay. Okay, so this is how you would compute, okay, your hash tables using these collision mitigation schemes, okay, or collision handling schemes. Okay, thanks for watching. Hope you enjoyed the video.